Hello students, welcome you to this session. So we are studying set relations functions. So sets we studied, then relation. Last video I taught the different types of relations, reflexive, symmetric, transitive, then equivalence relation. What is reflexive relation? Every element related to itself. Then symmetric, if A related to B, then B related to C. Some condition is there. And transitive also condition. A is related to B and B is related to C, then A must be related to C. If all the three relations satisfied, you know it is equivalence relation. So we'll continue the next to sum number 4, exercise 1.1, the fourth question. Just go through this question. Let P be the set of all triangles. P be the set of all triangles. Sometimes they give numbers. Here they given triangles in a plane. And R is the relation. So when can you say two triangles are related? Now they are explaining it, right? Let R be the relation and defined on P, because P is the set of all triangles. A related to B. A is a triangle, B is a triangle. Two triangles are related when? If A is similar to B. If A is similar to B. So listen, some of the properties of triangle, you know, similar triangles and congruent triangles. So question they may ask like that also. So what's the difference between similar and congruent? Similar means same shape, right? Same shape but different size. Suppose ABC is a triangle and PQR is another triangle. So they are similar. ABC and PQR are similar. Then what can you say? The angles are equal, corresponding angles. Angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. Corresponding angles are equal, but sides, they are not equal, they are only proportional. That is AB by the corresponding side there, it is PQ, equal to BC by QR, equal to AC by PR. This is what you can say in similar. But in the case of congruent, you know, congruent means same shape and same size. So ABC is one triangle and PQR is another triangle. Here also the same result. The three angles are equal. All the corresponding angles are equal. Sides are also equal. In similar we say sides are proportional, but here the sides are also equal. That is AB is equal to PQ, BC is equal to QR, AC is equal to PR. Okay, so these are the difference between similar triangle and congruent triangle. Actually, you don't need to write all these things just for you to understand what it is. Okay, so question they may ask, similar triangle or congruent triangle. So both you can say they what satisfy equivalence relation. Okay, so now we have to prove it is equivalence relation. Now listen here. So let us check the properties one by one. So the first you have to check what? First you have to check reflexive property, right? First one is reflexive. Listen here, I'm taking three triangles. So this is one triangle, all similar triangle. This is the second triangle. This is the third triangle. Suppose I'm taking this is triangle A, triangle B, triangle C. Is it reflexive? Reflexive means every element related to itself. Every triangle is similar to that triangle. Triangle A is similar to triangle A. Triangle B is similar to triangle B. Triangle C is similar to triangle C. It is true only, right? So it is reflexive. What about symmetry? A is similar to B. Then B also similar to A only, no? Same shape only, right? Or B is similar to C, C is similar to B, A is similar to C, C is similar to A. So it satisfies symmetric. What about transitive? A is similar to B and B is similar to C. Can you say A is similar to C? Yes, they are also of the same shape only. So all the properties satisfied. It is an equivalence relation, but now how to write? Okay. So we are going to generalize and write. Okay. So here every triangle is similar to itself. Therefore, that is A is related to A. So A is a triangle. Okay, A is similar to A. Therefore, it is reflexive. Then the second property is what? Symmetric, right? So next you write symmetric. So triangle A is similar to B means triangle B is similar to A. So if triangle A, if triangle A is similar to triangle B, then triangle B is also similar to triangle what? A. So that is A related to B implies what? B related to A. Therefore, it is symmetric. And the third one is transitive. The third property is what? Transitive. So like this words also you can write, or I am going to write directly. So here A is similar to B and B is similar to C. Then definitely you can say A is similar to C. So therefore it is transitive. So all the three properties satisfied, therefore you can say it is an equivalence relation. It is an equivalence relation. Okay, now let us go for the next question. Listen here. On the set of natural numbers, now that is important, set of natural numbers given, natural number 1, 2, 3, 4, etc., right? On a set of natural numbers, let R be a relation. And how they are defining, A is related to B. We can say A is related to B if a condition satisfied. What's the condition? 2A plus 3B equal to 30. A is related to B if 2A plus 3B equal to 30. If this condition satisfied, then you can say A is related to B. So now we have to find the ordered pairs which satisfy this condition. Last class we did one question. We couldn't find anything, right? Because a natural number, some multiple of another natural number, when add, you have to get one. Not possible, the empty relation. And remember, empty relation is not reflexive, right? For empty relation, you can say symmetric and transitive. But empty relation is not reflexive, so that you remember. So here what you can do now, the possible values you have to find, it should not be fraction because the given set is what? Natural number. So the lower classes we do now, for to draw a line, we find the points, right? But here, there we find 2 or 3 points, but here all the possible ordered pairs you find out. But both A and B are natural numbers, okay? So I find Y from here, instead of Y we have B. So 3B is equal to 30 minus 2A, or B equal to 30 minus 2A by 3. For A, you give some suitable values and you find out the corresponding B values. So we are going to find A value, B value. So for A, you substitute, you can't simply put any natural number, right? Because denominator 3 is there, okay? So 30 minus some multiple of 3, if you get, then only you can cancel, right? Numerator must be some multiple of 3, then only the 3 you can cancel, right? Then 30 minus, so 1, 2 and all, if I give 1, 2 into 1, 2, 30 minus 2, 28 you cannot divide. So 3 you can give only for 3. So you put A equal to 3. When you put A equal to 3, 2 3s are 6. So 30 minus 6, 24. 24 divided by 3, you will get what? 8. Then you can give 6. So 2 into 6, 12. 30 minus 12, 18. 18 by 3, right? So you are getting here also 6. Then you can give 9. 3 tables you give. So 2 into 9, 18. So 30 minus 18 is 12. 12 by 3, you are getting 4. So 9 we are given. Next you give 12. 2 into 12, 24. So 30 minus 24 is 6. 6 by 3, it is 2. Next you give 15. If I give 15, 2 into 15 is 30. 30 minus 30, 0. 0 by a number is 0. But you can't take that. 0 is not a natural number, right? So these are the values you can take. So this is the table you are getting. So now you can say the relation, right? You can write it as set of ordered pairs. Okay, so all the possible values you got it. So the set of ordered pair, what is that? 3, 8. First one. Second one is 6, 6. 9, 4 and 12, 2. So relation, so you have to write it as a set. Set of ordered pair. This is the relation. This is the first part they asked, right? Write down the relation by listing all the pairs. So that part we finished. Now check whether it is reflexive, symmetric, transitive, equivalence. When can you say it is equivalence? If all the three satisfied, we say equivalence. So you have to check everything. First you check reflexive, symmetric, transitive. Then you go for what? Equivalence. Suppose sometimes in the question they'll ask check whether it is equivalence relation or not. Only they ask check whether it is equivalence. You check reflexive. If not satisfied, you stop there itself. Don't need to go for other two, right? Even one is not satisfied, it is not equivalence relation. Sometimes you are so thorough, okay, it won't satisfy symmetry. Then you write that alone, that is enough. Symmetric, you check. If it is not there, you say since it is not symmetric, it is not equivalence relation. No need to do all these. But it is an equivalence means everything must be satisfied, so you have to check everything. But for this question, whether it is equivalence or not, they asked to check everything. Check whether it is reflexive, symmetric, transitive. Then finally, you have to say about what? Equivalence. So we do one by one. First, let us check reflexive. So first one is reflexive. Reflexive means every element related to itself. Just try to understand the theory part thoroughly. Every element related to itself. Every element means every element of what? The given set. What is the given set? Set of natural number. So set of natural number. What are the numbers? 1, 2, 3, 4, etc. Every element related to itself mean. By that what we mean, 1 is related to 1, 2 is related to 2, 3 is related to 3. Everything should be there. None of them is here, right? So only that 6 is there. So that is not enough. Even one term is missing, you say it is not reflexive. So since it is not reflexive, just to show one example. So one example you give which does not satisfy. Okay, if it is reflexive, you cannot write everything. In that case, you write, in general form, you write A related to A. So it is reflexive, like that you can say. Okay, so if it is not satisfied, show just one example, that's enough. Here, 1, 1, 2, 2, 3, nothing is there, right? I'm going to write only 1. 1, 1 does not belong to R. Therefore, it is not reflexive. So to say it is not reflexive, even just one example is enough, right? Second one is what? Symmetric. Symmetric means not for everything. In the given relation, you check. In the given relation, if A is related to B, then B must be related to A. Simply, you no need to check whether 5 is related to 10, something like that. No. What is the given relation you check? See, first order pair is 3, 8. What's the meaning? 3 is related to 8. What is symmetry? If 3 is related to 8, 8 must be related to 3. Then you must have 8, 3. 8, 3 is there? No. So even that one is enough. You say it is not symmetric. Are you able to understand? Yes. So what that example we give. So here 3, 8. 3 is related to 8. 3, 8 belongs to R. But 8 is not related to 3. 8, 3 does not belong to R. Therefore, it is not symmetric. Next, the third one you have to check, it is what? Transitive. Transitive. Now listen, transitive means two conditions. A related to B, then that B, the continuity should be there. A is related to B, then B is related to C. Suppose 5 is related to 8 means you have to check for 8, whether 8 is related to some number. 5 is related to 8 and 8 is related to 10 means 5 must be related to 10. A is related to B, B is related to C. If both are there, then A must be related to C. If that relation does not exist, A related to B, B related to C, if that is not there, you don't need to write anything. You say it is transitive. Okay, so now let us see here. 3 is related to 8, right? 3 is related to 8. Then you check whether 8 is related to anything. In the first place, 8 is not at all there. So left side, it is not there. So no need to check the right side. A is related to B and B is related to C. Then only you have to check that one. Okay, look at the second one. 6 is related to 6. Then that 6 is related to anything? Only the same thing, right? So nothing is there. 6 is related to 6. Again 6 is related to 6. You are supposed to get 6 is related to 6. It is there. 9 is related to 4. That 4 is related to nothing like that. 12 is related to 2. 2 is related to nothing is there. So you don't have any right to say it is not transitive. A is related to B and B is related to C. Then if it is not satisfying A related to C, then you say it is not transitive, right? No such case is there. So A related to B related to C itself is not there. So no need to check anything. You say it is transitive. So it is transitive. So if you want, just you say the definition of transitive. Okay, so here A related to B. A related to B and B related to C. B related to C, which imply A related to C. A comma C belongs to R. So it is transitive. But the last one they asked, is it equivalence? It is not equivalence because it is not reflexive, not symmetric. So it is not an equivalence relation. Okay, so the last one, equivalence. Since it is not reflexive, that one itself enough, not reflexive and not symmetric. It is not an equivalence relation. So hope you understood this. Some writing work, so do it very carefully. Now go through the next question. Prove that the relation friendship is not an equivalence relation. Prove that the relation friendship is not an equivalence relation. Not an equivalence relation, that's all. Prove that. They didn't ask you to check. It is given. It is not an equivalence relation. You give one example. You say it not satisfy reflexive, or you prove it not satisfy symmetry, or you say it not satisfy transitive. Anyone, which one you are so thorough, you write that. Even that one is enough. It is not compulsory. You should do one by one. Here they didn't ask to, like previous question means what? They are all the 4 subdivisions. You have reflexive, symmetric, transitive, equivalence. Here they asked to check whether it is, prove it is not equivalence. Easily you can say it is not transitive. Other things you may have a doubt, right? What about reflexive? A is a friend of A. Can you say one person is a friend of that person itself? Some people may say, I am treating myself as my friend. It's up to you. Okay, so A is related to A. If you want, you can say you are your friend. What about symmetric? A is a friend of B, then B is a friend of A. It is symmetric, right? Then only we say friend. A is a friend of B means definitely B must be a friend of A, symmetric. But transitive, definitely it won't satisfy because need not be, very rarely, but in some case, even in one case it is not true, it is not transitive. A is related to B. A is a friend of B. B is a friend of C. A is a friend of B. A is a friend of B. B is a friend of C. Suppose A and B are school friends. Their residence areas are different places. They are school friends. B and C are friends in the native place. They are friends. But sometimes A and C, they may not know even, right? So they cannot be friends. They may be friends on Facebook. Okay, that's not here. Okay, so some cases it may be true, but in general it may not be. Okay, need not be. So A and B are friends, B and C are friends. It need not imply A is a friend of C. So we say it is not transitive. So since it is not transitive, you say it is not an equivalence relation. Okay, so here A is a friend of B. A related to B. A related to B and B related to C need not imply. Okay, A related to C. You can write like this, or you can write our usual way. A comma B belongs to R and B comma C belongs to R. What's the meaning of that? A is related to B and B is related to C, which does not imply, or you can say but A comma C does not belong to R. Therefore, it is not transitive. If it is not transitive, you know definitely it is not an equivalence relation. Therefore, it is, or friendship is not an equivalence relation. So, hope you understood. So like that some questions, brother of, sister of, Okay, just to go through that sums, but try to concentrate more on this sums related to mathematics. See this one, on the set of natural numbers. So that is the first thing you have to note. Whether it is given set of triangles or set of natural numbers, what set they given. So reflexive means in that set, every element must be related to itself. So here, set of natural numbers. So the given set is set of natural number, 1, 2, 3, 4, etc. Let R be the relation defined as R is a relation. How they define? When can you say A is related to B? If this condition is satisfied. What's the condition? The condition is A plus B less than or equal to 6. A plus B less than or equal to 6. A and B are two natural numbers. A and B are two natural numbers. If we add them, the sum is less than or equal to 6. Up to 6 you can take. Then you say A is related to B. So both A and B are natural numbers. Okay, the total you have to see. So what are, you can write R directly. You start with the first number. What's the first number? 1. So you can take 1, 1. A value 1, B value also 1. Why? You check whether it satisfies this condition. What's the condition? A plus B less than or equal to 6. 1 plus 1, add it, 1 plus 1 is what? 2. 2 is less than 6, yes. Then you take 1, 2. So once you start with 1, you go in some pattern. Otherwise, sometimes you may leave some terms, right? So once you start with 1, 1, 1, 1, 2, 1, 3, 1, 4, like that you go. Then you start with 2, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Then you won't leave anything, okay? So 1, 1. Then can you take 1, 2? Add it. 1 plus 2, 3. 3 is less than 6, you can take. 1, 1, 1, 2, 1, 3, 1, 4. 1 plus 4, 5 only, yes. 1, 5? Yes, you can take up to 1, 5. 1 plus 5 is what? 6. Less than or equal to 6. So 6 is allowed. But sometimes if it is less than alone, then 6 you cannot take. Only total should be 5. So you have to stop with 1, 4. Okay. So here 6 allowed. So 1, 5. Now start with 2. 2, 1 you can take. 2, 2. 2, 3. 2, 4 you can take. Because 2 plus 4 is 6. Now 3, 3, 1. 3, 2, up to 3, 3 you can take, right? 3 plus 3, 6. 4, 4, 1, 4, 2, that's all. 5, 5, 1. 5 plus 1 is 6. 6 you cannot take. 6, 1 means it becomes 7, right? So this is R. This is what they asked first. Write down the relation by listing all the pairs. Okay, so write down the relation. Now they asked to check whether this relation, you formed a relation now. Now we check whether this relation is for reflexive, symmetric, transitive, and equivalent. So you have to write all the steps. Now the first you check reflexive. Immediately you can say it is not reflexive. Why? Reflexive means every element related to itself. So every element means every element of the given set. What is the given set? Set of natural number. 1, 2, 3, 4, etc. 1 is related to 1. Yes, it is there. 1 is related to 1. 2 is related to 2. Yes. 3 is related to 3. Yes. But that is not enough. It must be true for all the elements. 4, 4, 5, 5, 6, 6. Nothing is there, right? Only first 3 are there. So just show one example. So you can say here 4, 4. 4, 4. 4 is not related to 4. Every element must be related to itself. So here 4 is not related to 4, 4 does not belong to R. That one example enough. Therefore, it is not reflexive. They asked to check everything. Suppose the question is check whether it is equivalence or not. Means here you can stop. It is not reflexive. You say therefore it is not an equivalence relation. Okay, now we go for symmetric. Second one, you have to check symmetric. Symmetric means what? Condition is there. If A is related to B, then B must be related to A. Which are not in the relation, you no need to check. Suppose 2 is related to 3, you check 3 is related to 2 or not. Okay. So see the first one, 1, 1. 1 is related to 1, even if you reverse 1, 1 only. 1 is related to 2. 1 is related to 2 is there. 2 is related to 1? Yes. Then 1 is related to 3. 3 related to 1? Yes, it is there. 1 is related to 4. 1 is related to 4. Then 4 must be related to 1. Yes, it is there. Then 1 is related to 5. 1 is related to 5. Then 5 must be related to 1. Yes, it is there. So I think everything satisfies, right? So Here A related to B, A comma B belongs to R, implies B is related to A, B comma A also belongs to R. Therefore, it is symmetric. Now we check the third one. What's the third one? Transitive. Transitive, here also the condition, but double condition, right? A is related to B and B is related to C. Then only you have to check it. If the left side does not exist, no need to check anything. A is related to B, then that B is related to C. Then A must be related to C. Now let us see. 1 is related to 1, then again that 1 is related to 2. Then 1 must be related to 2, it satisfies. Then you check something like that. 1 is related to 4. Okay, 1 is related to 4 and that 4 is related to 2. Then 1 must be related to 2. It is there. If it is not satisfied, just you show one example and you can stop with that. If satisfies everything, then you have to generalize and write. Okay. If you go down here, somewhere say 5 is related to 1. 5 is related to 1 and that 1 is related to, first and all you take, you may get this, anyone you take. 1 is related to 4. A is related to B and B is related to C, right? Then 5 must be related to 4. 5, 4 is here. No, only 5, 1 is there. 5, 4 is not there. So that one example enough. It is not transitive. So I'm going to take the same example. Okay, 5, 1, 1, 4. 5, 1. Here, 5 is related to 1. 5 is related to 1. And that 1 is related to 4. 1 is related to 5 is also there. Anyone you take. 5 is related to 4. But 5, 4 is not there. That is 5 is not related to 4. So A is related to B and B is related to C, but A is not related to C. So you can say, therefore, it is not transitive. So now the last one they asked, is it an equivalence relation? It is not equivalence relation because of two reasons. It is not reflexive, also it is not transitive. So since it is not reflexive and not transitive, even one not satisfied, you say it is not an equivalence relation. It is not an equivalence relation. Okay, now we go for the next question. Listen this question. Just to read that. What is the, A is one set, right? A is a set given, A equal to set ABC. What is the equivalence relation of smallest cardinality on A? And what is the equivalence relation of largest cardinality? Cardinality means what? Number of terms. So you have to find equivalence, find a relation which is equivalence. So that means it satisfies all the three, reflexive, symmetric and transitive. Smallest one and the largest one. You studied extreme relations, right? What are extreme relations? The two extremes. One is the empty relation, another one is the universal relation. Universal relation means A cross A. Empty relation, that is the smallest one. But here that alone not enough. Not only the smallest, also it must be equivalence. Empty relation means nothing is there. So empty relation is not reflexive. Reflexive means some element should be there and every element must be related to itself. Reflexive symmetric, no problem. So suppose it is not there, you cannot say it does not satisfy symmetry or transitive, right? So for empty relation, you say it is symmetric, it is transitive, but only thing it is not reflexive, okay? So it is not an equivalence relation. So you cannot take that as the smallest relation, okay? The equivalence relation with cardinal number, the smallest. You can't take empty relation. So For smallest, you have to form a relation. Say I'm taking R1. What are the elements in A, A, B, C? Reflexive must satisfy every element must related to itself. So A must be related to A comma A, B comma B, C comma C. Every element related to itself. If you write something extra, then symmetric you have to check it, okay? So here every element related to itself, so reflexive satisfied. Symmetric, you no need to check anything. It is symmetric because if I write A related to B, then B must be related to A. Then I need B comma A also, right? So then we keep on writing, it become a larger one. I want the smallest one which satisfy all. Okay, so here it satisfies reflexive, symmetry and transitive. Transitive means A related to B and B related to C. If anything is there, then only you have to check it. No, it is not there. Okay, so this is the smallest one, which is equivalence, which is an equivalence relation. So this is the answer for the first part. Now for the second one, again you have to give an equivalence relation of largest cardinality. Maximum number of elements, you give the universal set. That is what? A cross A. Okay, universal relation, that is A cross A. A cross A means you write every element, right? I'm taking that as a R2. ABC, ABC, right? A cross A. A is ABC, another A, ABC. So when you find Cartesian product, you will get 3 into 3, 9 elements, right? So only few, so you can write. Otherwise, you can write your answer as A cross A, leave it, okay? So here, only 9 elements, so I'm going to write A comma B, A comma C, then BA, BB, BC, CA, right? CA, CB, CC. Is it an equivalence relation? Check it. What about reflexive? A is related to A, B is related to B, C is related to C. Reflexive. Symmetric, A related to B, B related to A. A related to C, C related to A. Everything satisfied, right? Even associative, transitive. A is related to B and B is related to C, A related to C. Everything is there. All the 3 properties satisfy. So what can you say? It is an equivalence relation of larger cardinality. Okay, so you say which is an equivalence relation. Okay, so now let us go for the last question in this exercise, and this is one of the very important one. I think this is the only one 5-mark question. Like this, there is a 5 question in the example also. Okay, so if you listen this carefully, then you can do that example sums of your own. In the set Z of integers, you know what are integers? 0, 1, 2, 3, etc. -1, -2, -3, etc. Right? So this is set of integers. Okay. So what is the set given? So here Z is a set. Define M related to N. You can say M is related to N. When? If a condition. What's the condition? This is the condition. What's the condition? M minus N is divisible by 7. M minus N is divisible by 7. Divisible by 7 means exactly divides, right? Remainder is 0. See, 7, 14, 21, 28, 35, all these are exactly divisible by what? 7. Because all these can be written as 7 into some integer, 7 into 1, 7 into 2, 7 into 3. So a number is divisible by 7 means can be written as 7 into some number. Divisible by 12 means 12 into some integer. So you can write it as say 7c or 7k, where k is an integer. Divisible by 7 means you can take it as 7k, where k is an integer. Integer means earlier I said 0, 1, 2, 3, -1, -2. All these are integers. Okay. So again you see, when can you say 2 elements are related? Their difference. M is related to N only when the difference. What's the difference? M minus N. You will get an answer, right? That answer is divisible by 7. So prove that it is an equivalence relation. So listen carefully. So we check one by one. The first you have to check reflexive. What's the meaning of reflexive? A related to A you have to get, right? If you get A related to A, then you can say it is reflexive. When can you say A related to A? the difference must be divisible by 7. What is the difference? A minus A. What is A minus A? 0. And 0 can be written as 0 into 7. 0 can be written as what? 0 into 7. So divisible by 7. Divisible by 7. So better, instead of writing 0 into 7, you write 7 into 0. Everything same only, right? 7 into some integer. 7 into 0 is an integer, right? So divisible by 7. So A is related to A. Therefore, R is reflexive. This relation is reflexive. So next you check symmetric, right? The second one you have to check symmetric. Please listen very carefully. The important step I'll tell you. So what is symmetric? A related to B, that they give, right? A related to B. You have to prove B related to A. Then you can say A related to B implies B related to A. Then you can say it is what? Symmetric. Now please listen here. A related to B. Then what can you say? The difference is divisible by 7. What's the difference? A minus B is divisible by 7. That is, A minus B is equal to divisible by 7 means 7 into some integer. 7k I am taking, where k is an integer. I am changing the sign throughout. Changing the sign. Multiply both the sides by minus 1. So that minus B become plus B, A become minus A. Okay, so B minus A is equal to minus 7k. Can be written as 7 into minus k. Minus k is an integer. Why? K is an integer, so minus k also integer. 5 is an integer, minus 5 is also an integer, right? So k is an integer, minus k is integer. So what you are getting here is 7 into some integer. 7 into some integer, so you can say which is divisible. Divisible by what? 7. Divisible by 7, so the difference B minus A, difference is divisible by 7, so they are related. So you can say B is related to A. So what you are getting now, that is A related to B implies what? B related to A. Therefore, R is symmetric. Now the third one. What's the last one? Transitive, right? The third one is transitive. Listen, what we have to prove. We write that first. Please listen. Transitive means A related to B and B related to C. You have to get A related to C. You have to get this result. When can you say A related to C? Can you say the previous step, what you are supposed to get? The difference is divisible by 7. That is, you are supposed to get A minus C is divisible by 7. If you get a result like this, A minus C divisible by 7, you can say A is related to C. Then we say R is transitive, right? Let us see from here how to do this. A is related to B. What's the meaning? The difference, A minus B, is divisible by what? 7. And B related to C means that difference, B minus C, is divisible by 7. Both together you are getting. Okay, now please listen here. So what can you say now, which implies A minus B divisible by 7. So A minus B is equal to 7 into some integer. I am taking the integer as what? Say M. And B minus C is divisible by 7. Divisible by 7 means you take it as what? 7n I am taking. Okay, so I am taking one as 7m, another one as 7n. But remember, m and n are what? Integers. Okay, where m and n are integers. But the answer, what do you need? A minus C. So what we are going to do, no? Very important step. I am taking these as to equation 1 and equation 2. So we are adding 1 and 2. 1 plus 2. So add the left side separately. If you add the left side, what do you get? You write the step. So what you are getting? A minus B plus B minus C. Equal to right side, you add 7m plus 7n, right? You are adding this right side. 7m minus 7n. Left side, can you cancel any term here? Yes, minus B plus B get cancelled. So what you are getting? A minus C equal to 7m plus 7n, right? So that is A minus C equal to what is common? 7 into m plus n. 7 into some integer. Is it an integer? This m plus n is an integer or not? It is an integer. Why? You know, m and n are integers. M and n are two integers. If you add two integers, your answer is again an integer. So 7 into some integer, you are getting 7 into some integer. So you can say that is divisible by 7. Divisible by 7 means difference is divisible by 7, so they are related. A minus C is divisible by 7, so A is related to C. So what you are getting now, so that is A related to B, we started like this, right? And B related to C, and you arrived, which implies A related to C. That is R is transitive. All the three relations we proved, right? It is reflexive, it is symmetric, it is transitive. All the three relations satisfied. So conclusion, you can say, therefore, R is an equivalence relation. So very important one. So only thing they can, sometimes they change the number. Instead of divisible by 7, they can give some other number. You can practice it. So very simple thing. The three relations you must be thorough. What is reflexive, what is symmetric, what is transitive. Hope you understood all these things. Go through all the example sums. In the next video, I'll teach functions.